foundation for giving me this chance to share my research. Today I would like to talk about some of the research I just recently started doing in South Africa with some of my colleagues from Australia and the United States. So before I begin going into deeper in the topic, I want to go through the human evolution lineage to sort of put in context of the research topic. Recent genetic evidence has suggested much greater complexity in the evolution of the hominid lineage. It's not a simple straight line of a straight family tree. Instead, it's an intertwined, much more complex relationship between these various hominid groups that's been identified. It's not very clear, but this goes back to 7 million years ago, where we have the earliest hominid fossil that's been dated back to, and we believe that the human lineage diverged from the chimpanzee lineage somewhere along this line. We can really put in three major changes throughout the human evolution lineage along this line. First is the appearance of stone artifacts that dates back to about 2.5 million years ago. It really occurred around this time point between the divergence of our Homo lineage to the more ancient Australopithecus, sorry, I didn't sleep last night, so Australopithecus lineage. This is the first point where we see stone artifacts showing up, and there's something that is indicative of the modern human condition that's starting to emerge. If we think about our Homo sapien lineage, we're very much dependent on technology, and this is the first time we see the emergence of some kind of use of systematic production and use of artifacts. Around 1.8 million years ago, we see the first expansion of hominid species outside of Africa. And we see Homo erectus spreading out from Africa into Europe and Asia, all the way down to Southeast Asia. And then finally, the third major change throughout this lineage is the emergence of modern human behavior. And that's really characteristic of our species, not only anatomically modern, but also behaviorally modern. So that's really the topic I want to focus on. And you can see modern human, the emergence, is at the very end of this human evolution tree. And we have Neanderthals over here and the Homo erectus, and quite a famous hobbit from Indonesia up here, Homo floresiensis. So the topic I'm talking about here is actually just a very small part of the human evolution. I sort of want to put that in context. So the big question really is, what makes modern human modern? And there's really two aspects to that. There's a biological aspect, there's a behavioral aspect. If we talk about the biological aspect, the earliest fossil that bears any characteristic that resembles modern humans, our species, dates back to about 200,000 years ago in Ethiopia. And it's really these three skulls that's quite famous for showing these characteristics. It's Omo 1, Omo 2, and Hertel. This is the reconstruction of Omo 1. And you can see that these skulls, if we compare them to the earlier hominid skulls, they're a lot more globular. They're more rounded instead of a more flat and elongated shape. But again, if you look at this brow ridge, they still have certain characteristics that's still what we call archaic. It's not as derived as modern human yet, but overall people agree that this is the first instance where we see modern human anatomically emerged. And the other aspect really is the behavioral part. What makes modern human modern? Biologically, these fossils may look modern, but do they actually act like modern humans? And that's really that big question. Most scholars, and I'm sure everyone here would sort of agree that the defining features of modern human that make humans sort of unique from other animals, even our primate cousins. We have culture, we have language, we have art, we have music, we have complex technology, and I think all these things, except music maybe, well represented right now in this room. We rely on complex technology, rely on language for me to share my research with you guys, and language, symbolism, all these things are quite characteristic to humans. But when did these traits actually emerge in an evolutionary point of view? It's quite an interesting issue. So before we talk about the emergence of biologically human skeletons. Now, we'll talk about the behavior aspect. The earliest point that we see changes in the archaeological material that suggest characteristics that resemble these modern human conditions appeared in northeast South Africa around this time point, 90 to 70,000 years ago. This is the period what we call the Middle Stone Age, and they contain a series of items that indicate things that behavioral traits that were not here before. So we're starting to get these quite standardized looking points. They're probably part of hunting weapons. They started making these what we call back microliths. There's very small flake inserts that's been modified as part of a composite weapon. And also for the first time we see humans shaping and using bone, which wasn't present before. All these seems to suggest a more innovative and complex technology that's starting to emerge. And also, what's more incredible is that we're finding engraved ochre, engraved ostrich eggshells, and also a marine shell that's been perforated to create beads. These are the first time we see something that suggests symbolism in the archaeological record. And again, this dates back to about 97,000 years ago. So here, this is sort of the bifacial points I was sort of talking about. They're bifacially worked, so that means that they've worked on both sides. They're quite standardized. These are these back microliths. They're basically fragments of stone flakes that's been blunted on one edge to make into inserts as hunting weapons, probably. We also have these bone tools. They don't look that spectacular, but these have polish and used trace on them. And interestingly, our hominid ancestors before this point never used bones in this sort of way. They used bone as hammers to make stone flakes, but they never actually used bones as other kind of tools. And this is the famous Katanda harpoon that has been identified in Congo. It goes back to 90 to 80,000 years ago. You can see that they have a series of barbs and then these grooves at the end. So this is sort of the technology aspect. And then the symbolic aspect, we're starting to see engraved pieces of ochre, and this was found in Blombos Cave in South Africa. You can see these a series of zigzag patterns that's been carved into a piece of ochre that's about that wide. It's not very big. We also find ostrich eggshells that's engraved on the outside. They have zigzag patterns, these grid patterns. They're different color because of chemical alterations, not actually painted. And we think that these ostrich eggshells were used as water containers. These are these perforated beads. They are perforated intentionally and they get transported inland from the coast. And these are likely stringed up as some kind of necklace or ornament. So all these behavioral changes are quite significant if we consider our modern human expansion. In about 70 to 50,000 years ago, modern human expanded out of Africa. And the question really is, what allowed modern humans to do that? They not only expanded out of Africa, they encountered a series of other existing hominid species, Neanderthals in Europe, Homo erectus in Asia, Southeast Asia, and recently genetic evidence suggests that there's other group called the Denisovans in the central Siberia area, Central Asia area. So what allowed humans to expand out of Africa and interact with species, and in the end became the only hominid species that exists today? What gave humans that sort of edge to, in a way, outcompete or survive conditions that other hominid groups didn't manage to get through? So that's sort of the behavior aspect. What is the evolutionary significance of these changes? So if we look back, just a quick summary, we have anatomically modern fossils showing up around 200,000 years ago in East Africa, but behaviorally modern evidence didn't show up until 70,000 years ago. So there's a time gap, and it's almost close to the 100,000 year difference. So the question really is that what's the difference? If we're biologically modern, but our behaviors stay pretty much the same as before, what caused these modern behaviors to emerge, and what's the importance of it that really make us unique today? So much of the research current research focused on South Africa. A lot of these evidence I showed before were found in South Africa. And there's really research in the Middle Stone Age. So this is the time period that I'm talking about. But so I mentioned before, these evidence didn't show up until 70,000 years ago. So that's sort of at the later point of the Middle Stone Age. And the South African Middle Stone Age is separated into 4 main periods. So we have the early Middle Stone Age, we have the Stilbay industry, the Howiesensport industry, and the post-Howiesensport late Middle Stone Age industry. After that, we get into the later Stone Age. I won't get into that, but this is sort of the focus of this talk. And really, I want to focus on the Stilbay and Howiesensport industry. This is when we find all these really spectacular materials, all these engraved pieces and these new innovative material culture that seem to suggest some kind of change in foraging patterns. Here's just a quick map of the sites that contain both Stilbay and Howiesensport materials in South Africa. The different symbols represent the dates, so don't worry too much about that. But you can see that there's a fair bit of sites represented in South Africa. But if we think about the scale, it's a big place. So we only really have a few data points for a big place, and it's such an important time period. So the question that we will face, me and my colleagues last year when we visited South Africa, is that we recognize a lot of these sites that I've just shown, they're cave sites. So these caves, most archaeologists love caves, and the reason you can probably understand is because they're stratified, meaning that things deposit on top of each other. So when we dig down, we can figure out the relative temporal sequence, which came first, which came later. We can also date them. We can date the sediments. So archaeologists, I don't want to use the word obsessed, but they kind of are in South Africa, over cave sites. If we dig open air context, they would dismiss that. Oh, you can't date that. That's silly. So we see that most sites are caves. They offer these advantages. They also offer great preservation in terms of bones and other markers of past climates. For example, pollen, micro mammal fossils. These are really useful evidence for reconstructing past environment. But there are certain patterns that's more alarming, is that there are certain industries, for example, Stilbay, they're less represented in these caves, but instead, people have identified them in quite a big abundance in the open air contexts. So people walk along the river valley and find a cache of Stilbay points, but we never find these Stilbay points in caves. So we get faced with this dilemma that if we only focus on caves, what does that actually tell us about modern human behavior? So if we think about the landscape, not focus on these points, what exactly are we getting if we only focus on these sites? So the question really comes back to what is the significance of modern human behavior? What makes it so interesting? One part of it really is mobility, is the ability to move. And if we think of modern humans, movement is really quite a key aspect to modern human adaptation. We can move long distances in very short time frame into places we don't even know before, into very unfamiliar territory. And these aspects may have played a key role that allowed modern humans to expand out of Africa really rapidly and then pretty much spread all around the world. And the occurrence of symbolic material during this time suggests the increasing complexity of social networks. It's sort of the expression of ideas, identities into material culture, and then being able to use these material culture to communicate, to signal your identity with other groups. If we contrast this with chimpanzees, for example, chimpanzees are extremely territorial. If one individual goes to another territory, they get killed. But humans seem to have the ability to go to other groups and negotiate or communicate with other groups and manage to cooperate, for example, or we can even manipulate these knowledge and create new social networks. And maybe perhaps this is the interesting aspect of modern human behavior that allowed humans to move so rapidly across very diverse and extreme geographical settings, from South Africa into out of Africa into Middle East and go all the way into an Arctic area, across into the New World. These happen quite rapidly, and what maybe this ability to use symbolism is really the key that allowed them to move so rapidly. So if we only focus on these cave sites, we can never really trace these movements of these early modern humans. If we only focus on these cave sites, we only see fragments and maybe a biased sample of the wider landscape pattern. So we're arguing that we need to pull back and change the scale of our observation from these cave sites to the wider landscape. But the question is, how do we do that? So last year, me and my colleague, Matt Douglas from Nebraska, University of Nebraska, we went to South Africa and then started a survey project in the Doring River Valley, located in Cederberg. It's famous for wine, if anyone heard of it, and wildflowers, apparently. So the goal really is to identify open air and then surface artifact scatters that dates back to the Middle Stone Age, either through dating or typological framework to identify them, to say these are Middle Stone Age, and analyze these artifacts and try to find a way to correlate these artifacts with existing cave sequences that people have been talking about, and create a landscape perspective of the Doring River Valley. So this is a close-up view of the valley. This is the Doring River. This is the Oliphant River is not shown here. If anyone's familiar with the geography, probably not of this area. Anyway, this is the Doring River, and preliminary survey has identified quite a few areas that have Middle Stone Age artifacts exposed on the surface. And sort of going back to the point I made before, that stilbate points are overrepresented in landscapes but not represented in cave sites. You can see that we're finding stilbate points on the surface, but we don't actually find the Howeson's port. So it sort of supports our idea that there is a differential preservation issue between caves and open air site, and maybe it has to do with activities, how these materials were used. But this is a really promising start that we're finding the missing fragment that we're hoping to find. So this year, in August, we went back to the Doring River. Here's Doring River. This is the biggest drainage in the Western Cape region, the Oliphants. And then there's a smaller river, Beetle River, that comes in and meets the Doring River. You can see these pins, these yellow pins. These are cave sites. These three are open air areas we identified. So if we just ignore these for now and then say we only study these three cave sites and we try to come up with a scenario of modern human behavior, that's a bit silly, I would think, because you only have 3 points on the map. So what we're trying to do is to pull back and really do a systematic survey along the Doring River and also down the Beetle River and try to see what is exactly going on outside these caves. So this year we go to the area 8 Kraal, locality 1. This is a zoom in image. This is Doring River running on the side. The slope sort of goes up gently up to about this point, and it goes up quite rapidly to a stony ridge. This is a farm, a modern day farm, Afrikaans farm. These areas, this area, we've identified 3 surfaces that have exposed artifacts on the surface. They have adjacent in situ sediments that still have artifacts in them that provide pretty good indication that these things were likely intact at some point and then were exposed. And also the sediment allows us to date these sediments, hopefully. We're trying to do that. So this is another view, just a general view of the area. Again, this is that ridge that I was talking about. This is actually looking towards the river. You can't really see the river because you see the other side of the river here. And this is that ridge that I was talking about before. River's on this side, and the surface just slopes up this way. You can see that this area is quite brown. There's no vegetation. And that's probably the reason why the artifacts are being exposed. All these stones are Middle Stone Age artifacts. Here's actually a cluster of about 800 artifacts in this small area. And these gray spots, they're all flakes. We found Howeson's back artifacts on the surface. We also find stilbate unifacial and bifacial points. These are quite diagnostic. when you find these artifacts, you kind of know where you are in time, which is quite amazing. Surprisingly, we also found earlier stuff on the surface. These are Schulian hand axes that goes back, it's quite a big time frame. We don't have dates for that because it's on the surface. It's 1.8 million years ago all the way to 250,000 years ago where we find these Schulian hand axes all across the world, in Africa, all the way in Asia and Europe. We found these actually closer to a river in UPK 1-3 survey area. So here's the river. So that sort of suggests that this small area is actually quite a complex surface. You have a surface that's been exposed that contains artifacts that goes back potentially 1.8 million years ago. And then right over here, we have Middle Stone Age artifacts that goes back to about 70,000. So what led to the formation of this record is really the key question. And the first question we asked when we got there really is, why do we see these artifacts on the surface? And what's the reason that these artifacts are sitting on the surface and they look actually quite fresh? They're not really disturbed. They haven't been rolled around. There's a very little size sorting. So if you imagine there's a carpet of artifacts on the ground and it's been disturbed by erosion or by water, there will be some sort of sorting in their size because smaller stuff will get washed away. We don't actually see that. There's actually quite a rich artifact on the surface. And also, various evidence point to very recent erosion that exposed these artifacts, including pedestaled artifacts. So here you have a rock. There's a sediment that sort of pedestaled the artifact up. This is quite characteristic of recent erosion that's washing the sediment away that's around the artifact, and the artifact's actually protecting the sediment below. So this all points to a very recent exposure event that led to the artifacts to show up on the surface. And we're sort of speculating that the reason is from farming over grazing, where these vegetations, you can see here, they're sort of holding up the sediment. Once this bush dies, all these sediment will be gone. And actually, every day, these guys will go past us, and they're just eating everything in a way. And also, the sediment's so fine in the area, so when it rains, it actually floods up really quickly, and the sediment will collapse and get washed away in blocks. So what we're worried is that if we don't control, like go in and document artifacts right away, these things may be gone in 2 or 3 years. So it's actually quite a big task to go in and really do a theoretically informed, well-planned research in these settings. So we went in, first of all, we want to document the topography and the natural setting of this area. So we used differential GPS. Here's my colleague Alex using it to record topographic points. We also made 3 photogrammetry models of the surface, ground level, but also aerial photos by using a kite. It was kind of fun, but a bit scary also. You can see that it's fisheye because it's a GoPro camera, so we have to find a way to calibrate that. We also made 3D models of these surfaces to understand the topography. Through this, we can understand surface runoff, how sediments move in terms of the slope angle and where the sediments discharging. And ideally, we will make these models every year to compare them and see how fast the erosion is happening. And so here, the 3D model, you can see that all these stones are showing up quite nicely. And here's a gully that's formed by erosion. So sediments are basically washing down from these upper intact sediments down to this gully and then get carried away. So we came up with this method based on some approaches done in Australia and Egypt in surface archaeology. Basically, we record the position of every artifact that's bigger than 2 centimeters on the ground. We pin it out with a nail. Every piece has a unique ID that gets taped on the nail, and then we record the 3D positions of these artifacts. And you might ask, why do we do that? The reason really is to monitor movement of these artifacts. Do we see movement? Do we see change next year and the year after? Are these things going away? We also take sediment samples to try to understand the age of these surfaces and, more importantly, the history of these sedimentation. So again, here's my colleague Matt trying to record every single artifact that's on the ground. We then do in-field analysis of each artifact. We don't take these artifacts away, we leave them in the ground. Part of the reason is that we don't have a place to store them. So over 2 weeks, we analyzed over 1,500 artifacts. You can see here, there are two pieces. Some of them actually refit onto each other, which is quite nice. Again, this suggests a recent exposure that hasn't been disturbed. We do in-field analysis, and the data instantly creates a database. So we have all that ready. We haven't got to analysis yet, but we have the data ready. Actually, my colleague Alex is actually right there across the river on another locality doing the same thing right now. So hopefully everything goes well. Also made 3D models of the artifacts, 3D hand axes using photogrammetry. Again, you might ask why we do that, because it's kind of cool. But also, the information we can extract from 3D models, that's more difficult to extract from manual caliper measurements. So my colleague in Cape Town, Alex Sumner, is actually doing analysis on these hand axes. And we actually have a pretty big collection of hand axes at 53, and that's pretty rare. So I want to sort of wrap this up with some general photos of the area, but to sort of go through some of the main research questions that we hope to address with this project. One thing really is that how do we relate these innovative and novel material culture we see in Stilbe and Hawaiian sport? How does that tell us about these early modern human ancestors, their ranging and mobility patterns? And more importantly, do we see a greater capacity to move long distances within pretty short periods of time, or a more extended territory in terms of their foraging area? And further, to go further into the evolutionary question, does this evidence corroborate with the idea that symbolic material occurring during this time period allowed humans to have a more complex and extended social interaction? It's a tough question to ask, but I think this is where we have to go in terms of this kind of research into modern human behavior. More importantly, is how does this pattern compare to pre-Stilbe and post-Hawaiian-sport industries? If you can remember, I said Stilbe and Hawaiian-sport is when we get these modern human materials. Before that, we don't. And then quite surprisingly, after that, we also don't. These materials pretty much declined and disappeared after the Hawaiian-sport. And there was a gap of 20,000 years until the later Stone Age picked it back up. So the question is that if these things showed up that indicate modern human behavior emerged, why did these things go away? And if we can explain that away that, oh, they just don't need those things anymore, can we make the same argument for the period before, that they were capable of modern human behavior, they just didn't express it materially? So we're hoping that by getting away from artifacts, getting into the wider landscape behavioral patterns, we can try to address some of these issues in terms of our modern human ancestors. So this is the sort of a general list of the future goals, but actually we're trying to find money right now, so whether these actually happen, that's another issue. So we want to systematically apply the methods we've developed this summer across the entire Doring River Valley. It's not an easy task, but we got a PhD student going on doing that, so that's always good. We want to get more samples to get good dates of these areas so we can correlate them better within a formational framework, and also to other archaeological cave sites in the region. And more importantly, we want to get away from these cave sites, but we want to put the record into a sedimentation and a geomorphological framework to understand how these things form and why we see them. And only by doing so can we address these bigger landscape issues. So I want to extend my gratitude to my colleagues and also the funding bodies that allowed this season to go well and to happen at all. Yeah. Thank you. Um, I'm afraid there's no right answer to that because people have always talked about we cannot equate modernity, anatomical modernity, with behavioral modernity. They're two different things. Um, right. Right. Okay. The main hypothesis right now is climatic change. It's some sort of climatic variability that force some kind of change in behavior, and maybe there's some the capacity to doing so is already exists. Um, yes. Right. Right. That's how the story goes right now. But again, that's always the question because symbolic thought, symbolic expression is not unique to humans. Primates have the ability to abstract certain visual cues into sounds, and other members will recognize those sounds. But humans have the ability to basically extract that abstract meaning and store it externally as symbols, as sounds, for example, and you guys would recognize the sound, and that can take the sound and build something out of it. So it's not a major change in a sense. It is a major change, it's arguable, but that capacity already exists. The ability to abstract ideas may have existed. The ability to organize these ideas in long-term memory already exists. But it's a step further to externalize and to materialize these ideas. And potentially the implication is that the ability to materialize these ideas allow these ideas to be manipulated and negotiated by people. So it's no longer just pure communication. There's actually, people can pretend, and we actually see that in hunter-gatherer societies. We often try to link certain groups of hunter-gatherers to certain language groups. But actually, in reality, is that people can change the language. And they can move from one area to another area, and they can switch the language just like that. So it's not like a cultural affiliation that we envision today with our passports. It's not actually like that. It's actually a lot more fluid. And maybe these kind of evolution change is what we're seeing with these symbolic behavior that's showing up. Yep. Yep. And I think that's a very good question because that's sort of the view we want to get into by breaking away from a more traditional sequential or cultural history sequence. And that's really the dominant view right now, that you have pre-MSA, you have Stilbe, Howiesensport, and then late MSA. It's a sequence. And in fact, if you look at cave sites and the dates, they do line up as a sequence. And people actually claim that if you find a Stilbe point, for example, you know you're in the Stilbe, you know your date just by looking at the artifact. Sort of like with ceramics. But the question is that, can we get away from these more static view and then look at land use? And I think your point is really good. How come we're seeing Stilbe points out in the landscape and not in caves? And if they're different periods, okay, they're different periods, they're doing different things. But if they're the same period, they're doing different things at the same time. It's the same group, different group. That's the sort of question we want to get into. Yep. Sure. Yeah. 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 Thank you for that. That's a really good comment.